So here we are in the web app dedicated to create a supply chain model. And here you can see that we are building members and the components of the supply chain one after the other. So here we have the main component, which is an Atlanta company that is building electric skateboards. Here we are building the Mexico supplier in charge of providing the Atlanta company with wheels to build the electric skateboards. Here we are creating a second supplier who is in Florida, and this one is interesting because it's providing two types of components: engines, but also batteries. Then we are creating, still in this web app, we are creating a third member, which is another supplier, and this supplier is in China, and this supplier in China is also providing the Atlanta company with batteries. The fourth one is providing woodboard. So it's a supplier which is actually in France, and it's providing woodboard for the electric skateboards. And finally, the last one is also a company in Europe. It's in Sweden, and it's also providing the Atlanta company with woodboards for the electric skateboards. So we have to connect all suppliers with the maker, so with the Atlanta company, and we have to explicitly define each connection and describe which, and select at least which component is provided through these connections. So here you can see that we're connecting the French company with the Atlanta with woodboard, and same thing for the Swedish company providing also woodboard. So now it's time to create the customers. So we'll create three clients. The first one is a company in Los Angeles. So you can see this first company. The second one is actually in Italy. So it's more in the domain of ski, while the first one was more in the surf domain, and the last one is also in the ski domain. It's in Canada. And so these three clients are buying electric skateboards from Atlanta. They are actually buying the electric skateboards with the different prices. And so you can see the three as retailers, for example. And for each of them, actually, we should define the cost and so on. We also define a specific partner, which is the partner in charge of the transportation of everything. So we could have several transportations, but here we have only one. So now we are in the virtual environment. So this is a three-floor environment, and each floor has its own objective. So we will go first to the shipment floor. So here we are at the shipment level, where we can see that we have orders from our three customers, so Los Angeles, Italy, and Canada. And we can see that we already had from T-1 some orders of 30, 120, and 200 electric skateboards from these three customers. We're at month 0 now, but we can see that they have orders that have been predefined at T-1. We can see the stocks of electric skateboards. Here we have 500 electric skateboards. So now we will use one of these machines here to ship the to each customer. So we select the customer. Here we select Los Angeles, and we have 200 expected skateboards, and we can use these levers to define how many skateboards we want to ship them. So they order 200, so we'll ship 200 to Los Angeles. We can do the same for the other customers. So we can select Italy or Canada, and we can select the appropriate number of skateboards to ship. Also, depending on how many we have in stocks, but we see that we still have 250 or 200 and something in stock right now. So we will be able to ship to all of them. And here we have other connected colleagues that are also dealing with this shipment. So now let's go to the production floor, which is the second floor. And here we have, see that we have already some production that has been launched, and we can see that we have the stock of raw material. We have engines, batteries, and wood board and the wheels. And here we have the bill of materials to produce one batch of electric skateboards, one batch of 100 electric skateboard. We see that we have 1,100 wood boards, 500 batteries, 600 engine, and we also have 2,400 wood boards. So based on that, wheels, sorry. So based on that, we will define that the maximum that we can build is 5. So we cannot build, we cannot produce 10, but we can build 5 because we have a limited number of, I think it was batteries. So here we have the remaining, yes, we have 0 batteries remaining. So now we have launched the production of 5 batch of 100 skateboards, and we'll have to wait for them to be produced, which take one time step. So let's go to the final floor, the last one, which is the ordering floor, where we can order raw material. We see that we have already some orders that have been done at T-1, which is a predefined setup of the use case, and we see that we have some orders that have been done to all our partners at Mexico, Sweden, Florida, China, France, and you see that at T0, some of my colleagues here are just passing some orders here, some batteries to China. 500 batteries have been ordered to China at T0. Now 1,000 wood board to France, and I can myself go and select the suppliers, select the product, and use the levers to order. Here I've ordered 1,000 wheels to Mexico. And here we have another 1,000 engine that has been ordered to Florida, and so on and so forth. So we can do all the orders that we need so that we can finish the round, and now we can move to the next months. There is a recap of what has been ordered, and you can see that we've just switched from month 0 to month 1. Now there's no more orders, so we'll have to redo everything. So we'll have to go to the shipment level first, or the shipment level to order to ship the product to our customers. So you see that we have everything that has been produced is now more. We have increased the number of electric skateboards. We now have 600 or 650, and so on. Can you show me an example of a KPI hierarchy for a company building electric skateboards in Atlanta, with suppliers in Florida, Mexico, France, Sweden, and China, and customers in California, Italy, and Canada? So here we have the KPI structures. So the global performance is represented with the product quality here, that is depending on the defect rate, product reliability, the customer satisfaction, the supply chain efficiency with the logistic cost, supplier reliability, inventory management, and the financial performance with ROI, revenue growth, profit margin. Can you show me an example of risks and opportunities for a company building electric skateboards in Atlanta, with suppliers in China, Sweden, France, Mexico, and Florida, and customers in California, Canada, and Italy? So here we have suppliers, some customers. So another supplier here, and basically what we can see here is that we have here we have another supplier. So these chains and this network represent risks and opportunities. So let's show, for example, one. Here we have let's take the global market here that may create the potential of that's the blue diamond here. Changes in global demand, innovation and technological advancement, and currency fluctuations. So that's what the global market can create. And we can see that there are risks associated with that. So here we see that, so that's the purple diamonds. We see that the innovation and technology advancement can create risks or opportunity with changes in cost and profit for international suppliers and sales. That is here, you can see it, and that may imply some of our that may impact some of our suppliers. It can also have the increased or decreased sales due to the change in global demand that may impact our customers. We also see here that we have the supply chain disruptions, and these supply chain disruptions comes from the logistic shipping that may create delayed delivery to customers that may impact our customers. So we have our product here that may be defective due to some component quality issues from some of our suppliers. So this is a quite complicated network, but all this network is actually representing the risks and opportunities that are related to the use case that we have described. So now let's switch to the another immersive environment. Here we are with my colleagues. Here, this is the space where we'll be able to define performance indicators and the risks and opportunities. So let's start with the performance indicators. Here you can see that we have a KPI, so key performance indicator hierarchy. So we have a hierarchy of key performance indicators. You can see that we have the root of the performance that is decomposed within two sub-level. One is the quality of service, depending on the on-time delivery of each of our customers. So on-time delivery to Los Angeles, Canada, and Italy. And we have the financial performance that is depending on the expenses and on the benefits. So, and on each of these, the final KPIs, here you can see the on-time delivery. We can see that this on-time delivery is the ratio between the amount of delivered product and the amount of ordered product from this customer. So that's the way we can build this hierarchy, and by making the description of each of the elementary KPIs and the aggregation from level to level until the final the root KPI. You see here we have another description of one elementary KPI. Then we can get the aggregation to get the root KPI. So now let's describe the risks and opportunities. Here we will start first with the simplest one. So here we have a risk that is based on the weather that can create the potential, which is the blue diamond here, the potential of a hurricane. The Florida warehouse is susceptible to this hurricane, and that may create, that's the yellow diamond here, and that can create the risk of stock destruction due to the hurricane. And here we have a little bit more complicated risk or opportunity, at least a potentiality. So here we have a YouTuber, and the YouTuber has the potential of communication. So we can order and pay a YouTuber to make a video about our electric skateboards that create the potential. That's the potential of communication, and it's a North America YouTuber, which makes both Canada and Los Angeles susceptible to this video, and that can create the potentiality of a huge order, of a bigger demand from these two customers. So here we have the set of risks and also the performance hierarchy. So now we are in the decision-making environment. So it's a very abstract environment. Here you can see that we have different panels. So I will immediately load the session that is based on the electric skateboard use case, and I will also load the risks and opportunities, and the KPI hierarchy that we have just seen in the other room. So here we are. You can see that we have this yellowish trajectory that represents the performance. The white line represents the time with the time steps. And on the floor, we have the KPI hierarchy. We've at the center the root, and then the second, the first circle is about finance and quality of service, and then we have the third layer where we have on-time delivery of Los Angeles, Italy, and Canada, and we also have the expenses and turnover. So here we can observe the trajectory, and the performance trajectory is actually okay when it's within this white cylinder or touching the white cylinder. That means that the performance reaches the target. If it's outside the cylinder, that means that we don't reach our actual target. We could have a way more complicated KPI hierarchy. You can see here on the floor, it's a way more complicated KPI hierarchy. And in that case, of course, the performance is evaluated with the different set of KPIs, so it's a different trajectory. So let's come back to our simple KPI hierarchy. And what we can do here is that we can observe how at months 4 we're good. We also have the risks and opportunities. So here we have the massive demand from Los Angeles, massive demand from Canada, and we have the stock destruction risk. So these 3 risks that we have identified in the previous room are present here, and they have a timeline. We can see a little bit further that they have a timeline that represents when they are available. We can also decompose the performance trajectory into several trajectories if we go to the first circle. So here we have one trajectory is related to quality of service, which is quite good actually, and the other one, which is about finance, which is less good. And we can see on the quality of service that we are almost touching the cylinder all the time, but we have two bumps. And we can even decompose to the next circle, and we can observe in detail the on-time delivery of Los Angeles, of Italy, and Canada. And we can see that the one from Los Angeles is always good, which is okay, because that's our most expensive customer, so that's why we deliver first to them. And then we have the on-time delivery of Italy that is quite bad, and Canada is in between. We have it's okay, but at the end we have an issue. And then we can observe turnover, and so each of the KPIs can be seen through its own trajectory, and we can of course group the trajectory to see the overall performance. So now what we will do is that we will observe the impact of one risk or another to the quality of the performance. So let's select, so we can select the massive demand, for example. And what we'll do is that we'll have to go to the moment where the timeline of these risks are available. So we'll move forward in time to reach the moment where these risks can actually be activated, so that we can observe their impact on the global performance, but also on the detailed performance. So let's move a few steps forward. So now you see that the sphere representing the risk is now within the timeline, so we can activate the massive demand from Los Angeles and the massive demand from Canada due to the YouTuber, and we will group the trajectories so that we have only one performance trajectory. And now let's observe the impact. Let's observe the impact of these events. So we have to select a demand forecast because there is no real demand in the future. So that's why we need to have a demand forecast. And now let's launch a simulation. And you see that these 12 more time steps have just appeared, representing the consequences of this massive demand after the YouTuber video. And we see that even if it's a massive demand that could look like an opportunity, it's actually not that good. I mean, the trajectory is never close to the white cylinder. So now let's decompose, and we see that quality of service, which was our best major indicator, is now very bad. we can see that it's not good. And of course, if we decompose again to observe the on-time delivery of Los Angeles, Canada, and Italy, we see that even the Los Angeles, which is our priority, is actually we do our best, but at the end, it's bad, and Canada is bad immediately, and Italy is also not in good shape. It's a very simple example, but it shows that because nothing has been done to prepare for this massive demand, then even if we have this massive demand, of course, this opportunity becomes a risk because we don't have the stock, we don't have the production ready for that, and we've just ordered and produced without considering that the potential of that very high demand. So what we have seen here is really that kind of immersive environment using simulation or AI can provide us with a predictive analytics in an immersive context that is based on this use case.